Algebra 2, target 29, I can add and subtract rational expressions. This is day 2. In the first day we looked at adding and subtracting expressions with the same denominator. As we move forward, we're going to look at adding and subtracting rational expressions with unlike denominators. But in order to do that, we're going to need to find least common denominators. So today's lesson is just on that idea of finding least common denominators. So for a rational expression, okay, the least common denominator of two expressions is going to be the least common multiple of the denominators. So to find the least common denominator, we follow these 3 steps. Okay, the first is going to be to write each denominator as a product of its factors. So we're going to completely factor each denominator. Then we're going to compare the 2 denominators and their factors, and we want to write a product, okay, consisting of the highest power of each factor, okay, that appears in either denominator. All right, and then step 3 is just going to be to simplify that product, okay, from step 2, okay, and then we'll have the LCD. All right, so if we take a look at this first example, okay, finding the LCD of 2 over 5xy and 2 over y cubed, our 2 denominators are 5xy and y cubed. All right, so 5xy is 5 times x times y, and y cubed is just y cubed. All right, so what we want to do then is write a product. Our LCD is going to be the product of the highest exponent of each factor that appears in either one of the 2 denominators. So we have a 5. Okay, we have x to the first power is the highest power of x that we see in either one of the denominators. And then y cubed is the highest power of y that we see in either one of the denominators. All right, so that would be our LCD, 5xy cubed. All right, next example. Okay, we have 3 over 8x squared and 1 over 12x. So our 2 denominators are 8x squared and 12x. All right, so 8x squared is going to be 2 to the 3rd power times x to the 2nd power. 12x would be 2 to the 2nd power times 3 times x to the 1st power. All right, so our LCD, again, is going to be the product of the highest exponent of each factor from either denominator. So we have a 2 cubed here, right, is the highest power of 2 in either one of the denominators. And then we have a 3 down here as the highest power of 3. And then we have an x squared here. All right, so when we simplify that, okay, 2 cubed is 8 times 3 is 24, x squared. That would be the LCD. All right, next example. We just had. All right, the next example, we have negative 1 over 3x plus 6 and x over x squared minus 3x minus 10. So the 2 denominators are 3x plus 6, okay, which has factors of 3 and x plus 2. And then x squared minus 3x minus 10 is our other denominator. And the factors of that would be x minus 5 times x plus 2. All right, so the LCD for these two denominators, okay, we have a 3 here, okay, and then we have an x plus 2 in both of them, okay, but both are just to the first power, so the highest power we have of it is x plus 2. And then we have an x minus 5. All right, so that would be our LCD, 3 times x plus 2 times x minus 5. Now, we could multiply that out as a polynomial, but we can, it's also with binomials, when you have binomial factors, it's certainly okay to leave that in factored form. All right, so again, okay, the step-by-step process, okay, for finding LCDs of rational expressions. Okay, write each denominator in factored form. Okay, so you've got to write the factors of each denominator. Okay, and then use the highest power of each factor. Okay, that appears in either denominator. Okay, and it's a product of those factors. All right, that'll do it for finding LCDs. The next part of target 29 is going to be adding and subtracting rational expressions with unlike denominators, which we're going to use this idea of least common denominators for.